what is a linked list in C#. I'm going to start with a definition, and then I'm going to move to some code examples where I will try to demonstrate how we can use them in our code and what their advantages are. So what is a linked list in C#? A linked list is a generic collection which represents a doubly linked list. This data structure is part of the system collection's generic namespace, and each element contains a reference to the next element and to the previous element, which allows for efficient insertion and removal of elements at any position in the list. And these are the main characteristics of the linked lists. As I already mentioned, they are doubly linked, they are dynamic in size, and the size of the list can grow and shrink dynamically as elements are added or removed. And they use non-contiguous storage, which means that unlike arrays, the elements in the linked lists are not stored in adjacent memory locations, which again allows for efficient insertion and deletion operations, but can result in higher memory overhead due to the storage on node references. And now let's take a look at some code examples where I can demonstrate how we can use linked lists in C#. Okay, let's start with a basic example. I'm going to create my linked list, which contains some integers, and I'm going to call it linked list equals new linked list. And now let's actually add some elements at the end of the list. So let's go add elements to the linked list, and we can go linked list add last, and let's actually add several elements. Let's make it 10, 20, and 30, and I need to remove this. And now let's add an element at the beginning of the list. So add element at the start, and we can do that by using the add first method, and let's add 50. Okay, let's make it 5, and we can actually print the elements in our linked list. So let's do that. For each, we can do console write line I. Let's run our program up to here and see the result. And you see that we first added the elements 1, 20, and 30, and then we used add first to add the element 5, which is now at the beginning of the list. So let's see how we can find an element and how we can insert an element after another element. So let's do that next. Okay. In order to find an element, I'm going to use the linked list node class, which I'm going to explain the difference between the linked list node and an element in a linked list. There is a difference, so let's actually get with our example first, how we can find an element. I'm going to go find, and the element that I'm looking for is 20, and now we're going to try to insert another element after this one, if this one is found. So I need to check that this node is actually not now, and then we're going to try to insert another new element after this one. So I need to go linked list and add after, and then we're going to use our node, and we're going to insert a new element. Let's make it 125. And again, we're going to print the elements in the linked list. So let's do that. And we see that we successfully found our element, and we managed to insert a new element, which is 125. Now let's actually try to remove an element, and then I'm going to go over the linked list node class. Let's try to again use our linked list and remove, and we're going to try to remove the element, let's say 1, and we're going to again print our elements to the console. And now you see that 1 has been successfully removed. Now let's take a look at the linked list node class and how it works with linked list. Now, if we check the properties of the class, we're going to see that the linked list node actually contains a reference to the list, to the next element if it exists, to the previous element if it exists, and also contains the element value and a reference to the element. So what is happening when you add elements using the add last or the add first methods? Like in my code example, up to here, we have added 4 elements, but this is what actually happens each time we add an element. A new linked list node is created and it is actually added to the linked list. Now I can change my code a little bit to demonstrate this, and we can actually, right here, when we search for the element 20, we are going to print the value of the linked list node object. And also we can try to print the previous and the next elements. So let's do that. So first we're going to print the node value, and we can do node value is node value, and we can try to print the next node value and the previous node value, but we need to actually check for now. So let's do that. So we can go next node value is node next. We're going to check for now. If it is not now, we're going to print the node next value string, and if it is now, we're going to actually print null, and we need to close the bracket, and in the same way we're going to try to print the previous node value, node previous, and again node next value string, otherwise null. So we're looking for the element 20. We should have 1 and 30, and also the 20 should be printed right here. So let's run the code, and you see that we have node value 20, next node value 30, and this should be the previous node value. Is 1. So this is how the linked list node objects are actually used with a linked list. Every time you add an element, a linked list node object is created, and it holds reference to the next and the previous node if they exist, and if they don't exist, this is going to be null. In C#, the list and the linked list support the same operations. But when it comes to a linked list, it is way more efficient when we need to insert or delete elements at any position. And I have a very simple code example which actually demonstrates that. We're going to insert in the middle of a list and a linked list, and then we're going to time it and see what the difference is. So I have 1 million elements, and inside this loop, we add 1 million elements to our list and to our linked list, and then we use a stopwatch to benchmark inserting 50,000 new elements in the middle. And then we're going to, right here, we're going to do the same with the linked list, and then we're going to time it as well and print the results to the console. And let's run the code and see if there is any difference. So we're benchmarking insertion in the middle, and the list took 2,826 milliseconds, and the linked list took 13 milliseconds, so the difference is quite huge. This benchmarking is obviously not perfect. There's quite a few things to consider. If I reset my linked list right here, before our benchmark, let's do that. I'm going to remove this, And if I reset my linked list, I should get even faster results. So let's see if this is the case. And again, linked list insertion 2823 milliseconds, and the list insertion and the linked list insertion, it's only 8 milliseconds this time. This is not a perfect example because in your actual applications, you are going to check for null. You can see that each one of these is a warning, since if we don't have any elements in our linked list, this can throw an exception. So this is going to slow it down a little bit, but the main point is that inserting or removing elements from any location in the linked list is much faster. And next, I'm going to summarize the advantages and the disadvantages of using linked list and list in C#. And here the advantages of using a list and linked list in C#. The list provides random access, which is faster when we access an element by index, and typically uses less memory compared to a linked list. On the other hand, the linked list provides very efficient insertion and removals and can grow and shrink dynamically with no need to reallocate memory. And that is all from me for today. If you like my videos, hit the like button, subscribe to my channel. Thank you for watching.